Okay, hi everyone. So in the tutorial also we started tutorial chapter 17, tutorial on sequences and series. Okay, and yesterday we only covered two questions. We only covered question 5 and question 6. Okay, so without further ado, let's start with question 5. Okay, so question 5 over here, right? Now let's read together without using GC, find the limit of sequence, the limit as r goes to infinity, right? So this thing over here, this concept over here, right, refers to the convergence of a sequence. So this is a very early part. Yeah, this is actually in the very early part of the chapter. Okay, we talk about convergence of sequence, and the convergence of a series is a different thing. Okay, so the convergence of a sequence, right, is that we want to find the limit of the sequence as the term goes to infinity. The term goes very far, whereas the convergence of a series talks about the like whether are we able to sum to infinity or not, right? Whether does a sum to infinity exist. Okay, so there's a difference between convergence of a sequence, convergence of a series, as mentioned in our summary lecture. Okay, so what do we do over here is that now I'm going to so let's start directly with part A. Okay, so first, as r goes to infinity, let's analyze what happens to this expression over here. So as r goes to infinity, right, this one over here, the denominator over here, will be very, very big. Correct? So 1 over a very big number will approach 0. So our UR, which is 1 over 2R plus 1, will approach 0. Okay, so this is just like that. Okay, alternatively, the other notation that we can write, it would be the limit of UR as R goes to infinity, right, be equals to the limit as r goes to infinity for 1 over 2r plus 1, right? So this one you analyze a bit, right? Then do the same analysis, then you go to 0. So these are the two different kind of notation that we use to talk about the convergence of a sequence, okay? All right. So generally both of them mean the same thing. Okay, it's just that the notation are different, but they mean exactly the same thing. Okay, let's continue with part B. Okay, now for part B over here, right, you can see that as r goes to infinity, right, let's analyze ur. Okay, now ur over here would be 5r minus 2 divided by 3r plus 1. Okay, so if you were to replace r with infinity over here, right, what happens would be this will be very big, this will be very big, right? And then you get something like infinity over infinity, which should not happen, right? This is what we call indeterminate. So we don't want this to happen. So we will use a special algebraic technique so that we can do and achieve something like this. Okay, so the trick is that we will divide by the highest power of the polynomial above and below. So over here, we will get 5 minus 2 over r over 3 plus 1 over r. Okay, and as r goes to infinity, this one would approach 5 minus 0 because 2 over r is very small. Okay, and 3 plus 0. Okay, because this thing will be very, very, very small. So this will be equals to 5 over 3. So this is the notation that we will follow. Okay, can, huh? Okay, now the other way to do it, the other notation would be, now same thing, the limit as r goes to infinity of ur, okay, would be limit as r goes to infinity of this 5r minus 2 divided by 3r plus 1. We will do the same thing over here. Okay, we haven't taken the limit yet, so we will keep the limit outside. So this will be 5 minus 2 over r divided by 3 plus 1 over r. Okay, so this one over here would be equals to 5 minus 0, so same thing, divided by 3 plus 0. Okay, so altogether this one would be equals to 5 over 3. Okay, so this will be for part B. Okay, very easy. Okay, Now, so I think at this point, right, let's discuss how do we check our answers. Okay, now in general, right, we check our answers using the sequence function within our calculator. Okay, so let's take a look at what is this over here. Okay, sorry, I think, yeah, sorry, okay, let me do something like this. Yeah, I think this is a better notation. Okay, so something like this. Okay, so first we will adjust the UR. Yeah, correct. Adjust the expression of UR, and then we take R to infinity. Okay, so let's go and check for part B. Okay, so for part B over here, right, first we need to go to our, what do you call this, our mode. Okay, now check that in this line, right, you have already the sequence selected. Okay, you press enter to select it. Okay, and then you go back to Y, you will see this page over here. Okay, you have your n minimum with your un, u1, u2. Okay, something like that. Okay, so let's try. I'm going to key in the expression for B, right? So this would be 5r minus 2, right? And then I have a 3r plus 1. Because we are looking for the term at the very, very far end, right? So what do? Is let's do some table setting. Let's hack our table first. We can start with 0, we can start with 1. I think we start with 1 because, yeah. So if we look at this, right, we can see that the table is like that, lah, right? 1, 2, 3, 4, and so on, right? Right? Yeah, so we can do something like this. Now, however, let's, because we want to look for the infinity point, right, it would be nice to skip a lot of steps. So the trick is that we will put in, now this triangle table, right, means that every step of the table, or what is the change per step. Okay, so for example, if I were to put like 50, okay, if I were to put 50, okay, so let's see. Okay, it's going to take a while to calculate, so let's double check our answer. Can see that it indeed, right, goes to like this big number, right? Big number over here. Okay, but if you want to be a bit more greedy, you can put maybe a table, maybe 100 lah. Okay, oh sorry. Okay, so that's really big. Yeah, okay, can, and then you can see that actually, yeah, you can try to find like the number lah. So you can see like for this one, 503 over 304, very close to 503 already, which is what our answer in part B over here. Okay, now let's do the same thing for part C. Okay, so over here, let's adjust our UR first. Now UR, okay, U of R square minus 2R divided by 3R square plus 4. So over here, same technique, we will need to make it to something like this, right? So we will divide by the highest degree, okay, highest power of R. So because of this, we will have something like 1 minus 2 over R divided by 3 minus 4 over 4 plus, or 4 over R squared. Okay, so same thing as R goes to infinity. What happens to this? Okay, so 1 minus 2 over something big would be 0 divided by 3 plus 4 over something even smaller, something even bigger would be 0 also. So this one will give us, yeah, so this one would be 1 over 3. Okay, it cannot be equal. Yeah, not equal. This one is like that. Okay, tends to 1 over 3. Okay, now the other notation, same thing. Okay, same notation. Okay, same working. Okay, and last but not least, do the substitution. 1 over 3. Right, so this is equals to 1 over 3. Just showing you the parallel between the two notations. So that would be for question 5. Okay, now let's move on to question 6. Okay, for question 6, right, over here, this one over here, the concept over here is we are going to evaluate, right, sums, or we want to simplify summation, okay, to find the final expression of the summation. Okay, now the thing over here is that because if we were to include numbers, right, it will be very easy, and your GC is capable of calculating these numbers. So I think as a basic practice, you should be playing with playing with numbers and working with the like easy summations, so that you can test that your theory and concept is as consistent to what is being calculated in the calculator, right? Now, however, because we are in A level, okay, so the demand of the question is such that we need to handle not just constants, but we need to handle a few different variables over here, or a few different unknowns. Okay, so the thing is that you need to be very clear what is a constant, what is an unknown, what is a variable. Okay, all these are unknowns, but which one changes and which one is constant. So for this case, right, this one, the r over here is our variable. Okay, r will change. We are summing from r equals to 0 to r equals to n minus 1. So the value of r changes every time we sum. Okay, whereas for n, this is the final number, and this is just n lah. Okay, so the thing is that n over here is a constant, r is a variable. Okay, so I will just quickly highlight my variable r, so that when I add, I don't mistaken I don't like, yeah, like mistaken which one is a constant and which one is a variable. Okay, so here I will propose two methods. Okay, here I'll propose two methods. So the first method is, now over here, right, let's take a look at what is this. We're going to sum from r equals to 0 to n minus 1 of this 2n plus 1 minus 2r. Okay, so let me quickly highlight. Okay, my r. Okay, this is my variable that I will need to take care of later. Okay, so let's take a look now. So the thing is that in order to sum it nicely, right, we will need to understand what is this first. Okay, and because we're adding up the terms in a sequence, right, so let's determine what are the terms within this sequence. Okay, so let's start with the first term. When r equals 0, first term is r equals 0, right? So when r equals 0, what is this? This is 2n plus 1, right? Now, when r is equals to 1, what is this? This is going to be 2n plus 1 minus 2, so minus 1. Okay? When r is equals to 2, right? This would be 2n plus 1 minus 4, so this would be 2n minus 3. Okay? Let's do one more to verify further. Okay, so I think you can do a bit math to see that it's 2n minus 5. Okay? Now let's check. What is this sequence over here? What kind of sequence is this? There is a common difference of -2, right? And because of this, this is an arithmetic progression, right? So we can sum this up by borrowing the results of the sum in an AP, sum of an arithmetic progression. How do we do this? We can do this with two methods, right? Okay, sum of this will be equals to, now, n over 2 first term plus last term, because we can easily find out what is our last term. Okay, or alternatively, you can make use of the basic formula n over 2, 2a plus n minus 1 common difference. Okay, also can. Yeah, but definitely this looks much easier lah. Okay, can now, so with this, right, let us do the summation, right, with using the first formula. Okay, let's see how that looks like. So over here, right, I'm just applying this formula over here. So first one, what is this n? This n refers to number of terms, right? So let's do a little bit of calculation of number of terms. Now, we can try to make sense of it, right? But sometimes, right, when the numbers are a bit inconsistent, right, it will be easier for us to make use of this technique. So I will take the top minus the bottom plus 1. Okay, so this would be just n terms, like that. Can right? So with this, okay, with this, okay, so let's see. Okay, so first I will apply the formula. So this would be n terms divided by 2. Okay, sorry, I better do, okay, this color. N terms divided by 2. Okay, and then bracket. Now, first term. Okay, first term is 2n plus 1. Last plus the last term. What is the last term? Over here would be 2n plus 1 minus 2 r. R is 2n minus 1, like that. Okay, now so let's simplify. So over here we have n over 2. Okay, so actually the algebra looks horrible, but you just need to see the structure. Okay, the structure is just like that. Okay, the algebra looks horrible, yes, but you just need to see the structure and persevere. Okay, look at the big picture. Okay, don't focus about you see this and then you feel very tough, that kind of thing. Yeah, don't be intimidated by this because you're already in A level. Yeah, okay, so something like that. So altogether we have n over 2. Oh yeah, it's a minus. Okay, so over here we have a 2n plus 4. Okay, so divided by 2 we have an n plus 2. Okay, as our final answer. So this right here is method 1. Okay, method 1a, right? Now then method 1b would be to make use of this formula. Okay, so this one also a bit hideous, so bear with me. So method 1b, okay, would be, okay, so from here this will be equals to, now n, okay, I have n terms, okay, divide by 2, right? So 2 times the first term, 2n minus 1, plus n minus 1, okay, with this n terms, okay, be careful, minus 1, the common difference is negative 2. Okay, you can make use of this also. So this would be n over 2, 4n minus 2, minus 2n plus 2. 2n plus 1, sorry. So this one first one is 2n plus 1. This one over here 4n plus 2. Okay, so here n over 2, I have 2n plus 4. So in the same way, this is n plus 2. N times n plus 2. Okay, so you can see that both methods equivalent results. Okay, so this would be method 1. Okay, which is to consider the AP, right? Consider that this is an arithmetic progression. Okay, and then what we can do would be to sum things up using the formula for AP. Okay, why is this hanging? Okay. Okay, let me close this off. 1, 2, 3, 4, 5. Okay, reboot. Nope. Nope, 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 nope. Okay, so let's go to the next one. T17. Okay. This one. This one. Okay, so let's go to the part B. Okay. Okay, now let's go to part B now. This one you can get from the video. Okay, part B. Sorry, not part B, part A, method 2. Okay, so the method 2 over here, right, would be to expand the summation. Okay, method 1 just now, right, is to recognize the pattern. Okay, recognize the pattern, right, and check that actually this pattern fits an AP. Okay, so method 2, let's check and see how does this look like. Now, but for this one over here, right, now we need to do a lot of changes for this to work. So this would be not the straightforward kind of working for this question. Okay, so what we need to do is, now we need to expand the summation like this. Okay, so we will need to sum, right, from, okay, the thing is when we want to sum things, right, we need to sum from 0, we need to sum from 1 to something lah. Okay, so it will be easier if we can start with 1. Okay, so with this, right, we need to change the limits over here, right? So if we want to start with 1, right, so this means that r minus 1 will be equal to 0, correct? So means that we need to take this, okay, and we need to replace r with r minus 1, okay? And because of this, right, when we analyze the top, okay, so this, when we replace r with r minus 1, okay, so r will be equals to n, okay? So these two are our new limits, okay? And then we need to change this over here as well, okay? So let's take a look at how this looks like. So this would be, now the lower limit will be changed to 1, the upper limit will be changed to n, okay? And this one over here would be 2n plus 1 minus 2 times of r minus 1. Okay, replace r with r minus 1. So your lower limit, upper limit change, your expression also change. So it's something like integration by substitution. Okay, so now let's simplify. So r equals to 1 to n, 2n plus 2, sorry, plus 3 minus 2r. Okay, so let's do this. Now we are going to sum. Okay, so let's break this out. So now we can distribute the sum like this. Okay, can break out the sum times 3, then minus 2 times of this. Okay, now so with this, right, over here, now take note what is our variable, what is our constant. So over here n is a constant, right? We're adding our constant n terms, correct? N terms, right? So technically speaking, over here we are multiplying by this n times. Okay, so this would be n times n terms. Okay, adding this n terms, so it will be n times whatever that is. Okay, similarly in the other side, right, we're adding 3 n times. Okay, now over here, right, now we are summing up, okay, the variable part. Okay, so summation of r from r equals to 1 to n. So what does this mean, right? This one is, this thing over here, right, is actually 1 plus 2 plus 3 all the way until n, correct? So how do we do this is, there is an expression, okay? There's an expression, shortcut or identity for us to use. So the summation from 1 to n is actually half n plus 1, okay? So how do we get this? This is actually from the AP formula I mentioned before, right? It's from the AP formula, okay? Half n, then first term is 1, last term is n, okay? So we can expand it like that. So yeah, so this will be a very useful, what do you call it? Very useful property or identity for us to use. Okay, so with this, let's simplify. We have 2n squared plus 3n, then minus n squared minus n. So this one will be n squared plus 2n, factorize out the n, so n plus 2. Okay, so it will be similar to what we have before. Okay, now alternatively, you can recognize that this is the constant part, so you just take n terms. Okay, technically you don't have to change the variable, change the dummy variable also. Okay, you know that this is n times of whatever this is, n terms times whatever this is. The only thing that you have to worry is to change the limits when you sum from 1 to n for this. Okay, so this is the only thing that we need to take note. Okay, but in general, right, so which would be the easier method? Of course would be to recognize the pattern and to recognize that it's an arithmetic progression. So your eyes need to be really alert, okay, to really see these patterns. Okay, so this would be for 6 part A. Now for 6 part B, right, now this one over here, let's take a look at what is this. Okay, our r, we need to sum our r square. We also need to sum 3 to the power negative r, right? So previously, right, if you are thinking of expanding the summation, we can, because we are dealing with the constant term, we are dealing with sum of r from 1 to n. Okay, Now, so the thing is that for this question over here, we are summing r squared. So we need to know, okay, we need to know the existence of the few things. We need to know sum of r squared, and sum of r cubed from 1 to n, 1 to n, from 1 to n. Okay. Now, for this one over here is an AP, right? Or you can try to remember the identity to make your calculation faster. For these two over here, right, this one is usually got formula, but it will be given by the question usually. Okay, but if you happen to know by hand, it will be also faster for you lah. Okay, it will be given to you to help to ease your memory load. Okay, can so the thing is that this AP1 is something that we need to adjust along the way or memorize and just apply. Okay, so something like that. So let's take a look at this. Okay, so what we are doing over here, we are going to sum part B. Okay, we are going to sum from n plus 1 to 2n of this term r squared plus 3 to the power negative r. Okay, so no choice, we have to split this up because these two are very different things. Okay, so let's split this up and analyze. Okay, I will write the 3 power negative r as 1 over 3 power r. Okay, so that we will see what it is later. Okay, first let's analyze the first one. Now we are summing r square, right? I told you before we need to know the sum of r square and r cube over here, right? But this one over here is given, and the ones that are given, right, r starts with 1, right? However, we are summing from, okay, we are this one, right, is summing from n plus 1 to n, right? So what should we do instead? Now, if we have sum from A to B, this is equivalent to sum of B, the big sum, minus of sum of A minus 1. We have seen this kind of thing in AP, GP. Okay, so it's the same kind of thing. So over here, it will be sum from 2n minus of sum of n plus 1 minus 1, right? So sum of n. Okay, so over here, okay, so r equals to 1 to 2n of this minus sum of r equals to 1 to n of r squared. Okay, so this is the first one. Okay, second one, okay, let's analyze this. Now, because if we don't have any identities for this, so no choice. What we have to do is to look at the pattern. Okay, so when r equals to n plus 1, so this will be 1 over 3 power n plus 1. Okay, actually, what is this? This is actually 1 over 3, okay, power n plus 1, right? Okay, let me write this out. So this one, right, can be equals to 1 over 3 power n and 1 over 3, correct? Agree? Okay, next term. When we have r equals to n plus 2, so what, 3n plus 2, right? Correct? So this means that we get 1 over 3 power n, right? We get 1 over 3, right? And 1 over 3. So actually, okay, something like that. If we look at one more term, the next term, 1 over 3 to the power n plus 3. So this one over here, we break it down, 1 over 3 power n, right? 1 over 3, 1 over 3, right, previously, and then we got the third one. Okay, let me, okay. Right? Something like that. Okay, so technically speaking, right, if you were to notice, right, what's going on, right? Okay, what are all these terms? This is actually a geometric progression, right? The common ratio over here, r equals to 1/3. Okay, can so I remove these two for space. So actually this is 1/3. So let's look at the number of terms. Okay, this will be a geometric progression, right? The common ratio 1/3. Now next, what are the number of terms am I dealing with? So it's n plus 1 to 2n, right? So I take the top number minus the bottom number plus 1. So technically this would be equals to n terms. I need to deal with n terms. Okay, so making use of the GP formula, right? Sum Sn for GP formula A 1 minus r power n divided by 1 minus r. Okay, so let's apply this now. Okay, so first term is 1 over 3 to the power of n plus 1. So this is the first term a. Okay, then it will be 1 minus 1 over 3 to the power of n, number of terms is n, okay, divided by 1 minus 1 over 3. Okay, next step, what are we going to do is we're going to expand. Okay, we're going to expand and see what is this. Okay, so over here, right, this is replacing r with 2n. So sorry, replacing n with 2n, we get, okay, 2n over 6, 2n plus 1, then 4n plus 1. Okay, then minus, okay, this one is n, so this one just apply the formula. This would be n plus 1, 2n plus 1. Okay, this one very straightforward. Okay, now then this one over here, I can simplify this chunk. Okay, I can simplify this chunk, okay, to, okay, I can simplify this chunk to maybe 1 over 2 times 1 over 3 to the power of n, then 1 minus 1 over 3 to the power of n, like that. Okay, no choice. Okay, something like that. Can all right, then let's do some expansion. We have okay, we take out common factors. Okay, so the common factors that I have would be 6 and 2n plus 1. Right, so take out common factor, we will have 1 over 6, sorry, n over 6. There is an n and an n over here. Okay, so n over 6, 2n plus 1. Okay, so this would be 8n squared plus 2n minus of n plus 1. Be careful, bracket. Okay, plus half 1 over 3 power n. So this one cannot simplify already, so this one would be just fixed. Okay, then on this side over here, I will get something like n over 6, 2n plus 1, 7n. Sorry, not 8n squared, 8n plus 2. Okay, so over here I have a 7n plus 1, okay, plus 1 over 2 times 3 to the power of n, 1 minus 1 over 3 power n, like that. Okay, so the expression looks very wonky. Okay, the expression looks wild, but don't worry, this is just, don't focus about the scary algebra. Focus on your concepts from summation, from AP and GP. Focus on the concepts where you can break down the big summation into two pieces of small summation. Focus on the concept where you sum from this to that. You need to take summation of that minus summation of this minus 1. Okay, can so this concept, so a lot of concepts packed within a single question or summation, but please do not be overwhelmed. Okay, don't get scared. Okay, instead you should rise to the occasion and try your best to do this. Okay, don't be scared about the algebra. Focus on the concept and apply your concept. All this you've learned already, you just need to sharpen them and see the situation and apply them. Okay, so this is the end of the tutorial for chapter 17, and yeah, so we'll continue the other questions in the subsequent days. Okay, so that's all for today. Hope you learn well, don't be scared, and yeah, just press on. Okay, bye bye.